In section 5.3, we're going to start investigating how do we find antiderivatives. So in order to do that, we have to look at some of these properties that they give us. So when we've talked about doing an integral, we talk about the area underneath f of x from a to b. But what I want you to notice is on this one, the order of integration is switched. This one goes from b to a. And so what happens is, in order to make this actually work and go from a to b, we flip the two in order, but we make the function negative. So that's going to be a really cool one that's going to come in quite handy. Number 2 says, what if I want to find the area from a to a? So if I wanted to find the area of a function from 2 to 2, I'm not going anywhere. So of course the area would be 0. Constant multiple rule comes in very handy. If I've got a number out front of a function, I can pull that number out front, do the integral, and multiply it at the end. Number 4 is that sum and difference rule, where if I have two functions added together, I can just do the integrals of each one separately and add them together at the end. Number 5 is the additivity theorem, and I want you just to make a little note. This one is just like the transitive property from geometry. And it says if I've got an area from A to B plus an area from B to C, then it's going to cover all of the area from A to C. Now, the last two we rarely, if ever, use. I've never even seen them show up anywhere on an AP exam, but this max-min inequality says that the minimum has to be less than the area, which has to be greater or less than the maximum of that particular function. And then the domination one, it sounds really cool to say that there's a domination function, but it just says if function f is bigger than function g, then the area underneath f is going to be bigger than the area under g. That one's just kind of common sense. So in example 1, we're going to use those functions up here. We're going to use all these rules and try to determine if these are possible to do. So what I want you to do, I'm going to tell you there's a few of them that are not enough information given, but they've told you that the area from -1 to 1 of f of x is 5. The area from 1 to 4 of f of x is -2. And the area from -1 to 1 of h of x is 7. And they want you to find these. If there's not enough information given, just write not enough information. So on letter A, they had the order switched. So that one we had to switch the order back the way it's supposed to be, and you make it negative. So opposite of -2 is +2. Now try B. For part B, I used the additivity property, the transitive property. From -1 to 1 plus 1 to 4 gives us an area of 5 plus -2, which is 3. Go ahead and try part C. For this one, I could pull the 2 and the 3 out, but make sure you're separating these. So it's 2 times f and 3 times h. And so it was 2 times 5 and 3 times 7. When I add those together, I get 31. I want you to try the remaining 3. For all 3 of the remaining ones, there was not enough information given. We don't know how the function is behaving outside of these parameters. I cannot say that this one is perfectly symmetric, so I can't say I can just cut this one in half. I can't say this one is perfectly symmetric, so I can just expand that area. And this one, we don't know what h of x is doing outside of -1 to 1. We can't continue to figure out what's going on from 1 to 4. So not enough information for any of those. All right, so that moves us into this average or mean value theorem. And it says if we have an integrable function, and first off we need to realize that if it's integrable, we know the function is continuous, then the average value is 1 over b minus a times the integral from a to b of f of x dx. This is an important definition. Please mark it in your notes. When we think about taking the average of something, we add up all the rectangles and then divide by how many rectangles there were. That's what this particular formula is telling us to do. So example 2 says find the average value of this function 4 minus x squared from 0 to 3. And they want to know, does the function actually take on that value at some point in that interval? So when we talk about average value, we have to do 1 over b minus a. So b minus a, 3 minus 0, times the integral from 0 to 3 of 4 minus x squared dx. So we've got 1/3 times this integral. Go ahead and plug it into your calculator, do fn int. And when we do fn int from 0 to 3 of 4 minus x squared dx, you get 3. So 1/3 of 3 is 1. So they're saying the average value is 1. So the second part of this question is they're asking, does 4 minus x squared actually equal 1 at some point in this interval from 0 to 3? So let's do the algebra. If I subtract 4, then I get negative x squared equals negative 3. So if I divide by a negative 1, I'm going to get x equals plus or minus the square root of 3. And I just need to know, is one of these two answers in this interval? And in fact, yes, positive square root of 3 is in that interval. So the ordered pair square root of 3, 1 would satisfy that condition. So there's that mean value theorem coming into play again. And it says if it's continuous on a closed interval, then that mean value theorem is going to work. I'm going to hold off on these two definitions until we get to section 4. So for right now, we're going to stop with just that average value and mean value theorem for definite integrals.